So hello everyone. Welcome to this session on making FHIRPath more accessible to clinical form designers. Today I want to show you an approach we have developed to simplify how clinical form designers create dynamic clinical questionnaires. Let me quickly introduce myself. I am Olim Saidov, a software engineer at Health Samurai. I work on the 8-box forms teams, building tools for clinical questionnaires. So what are we going to cover today? First, we'll look at why FHIRPath matters in clinical forms. Then we'll explore the common challenges. After that, I'll present our solution approach. And finally, we'll see everything in action with a live demo. So let's begin. Imagine a clinical form that knows when to show pregnancy questions or automatically calculates BMI as you enter height and weight and pre-fills patient information from their record. All of this is enabled by FHIRPath. It helps to transform static forms into dynamic, intelligent tools. But there is a gap between FHIRPath, what FHIRPath can do, and how it is accessible to clinical form designers. So clinical form designers often do not have any programming backgrounds. So for them, learning FHIRPath is a steep curve. We analyzed common use cases of FHIRPath in our form builder and found two main categories of challenges. The first one is syntax errors that prevent execution entirely. And the second one is semantic errors that produce incorrect results. So let's look at syntax errors first. So when clinical users write FHIRPath, they make predictable syntax mistakes. They write what makes sense to them, but FHIRPath has strict rules about quotes, parentheses, and special characters. These aren't obvious unless you have programmed before. And when something goes wrong, the error message is cryptic. Semantic errors. This is where the learning curve really hits. To avoid semantic errors, clinical users need to understand FHIRPath's data model, FHIR's data model, and how it uses collections, complex types, and choice elements. So everything said above should be handled by a tool, not by a designer. So after analyzing these challenges, we designed a solution that tackles both types of these errors. So the key insight is don't make users to learn FHIRPath syntax and FHIR's data model. Instead, build an interface that embodies this knowledge, one that guides them through valid syntax, handles the complexity of collections and types, and turns assumption into clear choices. So let's look at our solution. The first thing we did was reimagine how FHIRPath expressions are represented. Instead of text that users type, we use visual tokens like blocks. Those are interactive UI elements that represent each part of the expression. So let's see this long expression. You can see that every symbol in it is broken down into individual tokens. So each of these tokens is clickable, interactive. So there is a variable, a function call token, the operator token, the date value. So every piece of the expression becomes something you can see and interact with. But how does this representation actually helps prevent errors? So with tokens, we can control what comes next. Each position in the expression has specific context, and that context determines which tokens are available. No manual text entry means no typos, no syntax errors. Tokens only append to the end. You build expressions linearly, step by step. And at each step, the system knows exactly what is valid. After a literal value, you might add an operator or function call. After field access, you can navigate to child fields. Or after an operator, you are only available tokens, just like you are building a new expression. The position context guides you. You cannot make invalid choices because they are simply not available. So how do tokens actually work in practice? When you click them, they respond with appropriate UI control. This is not something revolutionary. It's just applying standard UI patterns to expression building. The implementation is straightforward. Each token type knows what kind of input it needs and represents the right interface for it. So the syntax generation happens automatically as user builds expressions. So when you select a date, the token handles the format. If you type a string, the token adds quotes and escaping. So when you choose a function, the token manages parentheses and arguments. So from the user's perspective, they are just building the logic. But from the system's perspective, we are generating syntactically perfect FHIR-paths every time. Now let's talk about preventing semantic errors. The first step is knowing what field actually exists. We load FHIR structure definitions directly into the system. When you are working with a patient resource and click Add button, add new field, the drop-down shows only real patient fields. The schema controls what appears in the interface. So users always stay on the right path automatically. Schema awareness tells us what field exists, but type awareness goes deeper. As you build an expression, the system tracks the type at each step and suggests only compatible functions and operators. Look at this example. We start with patient, access the name field that gives us a collection of human name. But when we filter it with where, we're still working with human name inside the argument. So the where function returns the same type, collection of human name, and then select transforms our type to whatever we return from the argument. So in this case, it's a concatenation of two string values, which is the string. So after that, when you click a plus button, which corresponds to adding new token, the system suggests you string-specific functions, which are start with, index of, replace, or join. So this wouldn't make sense on patient or human name, so they do not appear until we have a string. This type tracking happens continuously as you build. Every token selection updates the current type, and the next set of available tokens reflects that type. Let me explain the technical approach behind type-aware completion. So the system performs sequential type analysis through the expression, just like an ordinary evaluation. We start with context type like patient. When building a patient-related expression, the initial context determines what starting tokens are available. Each token is processed sequentially. The first token established base type, whether it's from literal value or field access or variable reference. The subsequent tokens transform the current type. If you access a field, the type changes to that field's type. If you call a function, it transforms based on the function's return type. For those interested in the implementation details, there is a QR code on the slide that links to my blog post about static type analysis in FHIRPath. It covers the algorithm, edge cases, and how we handle polymorphic functions. So let's now talk about what happens when form logic gets complex. So this is a real example, real expression from a clinical form. checking multiple patient conditions all packed into one long expression. When form designer build logic like this, two main problems emerge. First, it's hard to read. You have to mentally parse the entire thing to understand what it is checking. Second, when something goes wrong, you don't know which part failed. But we can make it much easier to work with. Here is the same logic, but decomposed into named variables. Each condition gets its own variable with a descriptive name. These names communicate business intent. You immediately understand what each variable represents without diving deep into technical details. The final expression becomes beautifully simple. It reads like a sentence. Anyone can understand this without FHIR-path knowledge. But how we know if these variables are working correctly? Can we test each piece? That's where real-time evaluation functionality comes in. So real-time evaluation works with together with expression decomposition to provide immediate feedback. As users define variables, each variable value appears instantly in the evaluation panel. This immediate visibility helps users understand their logic step by step. When error occurs, clear messages appear right at the point of failure. Users can correct issues immediately rather than debugging complex expressions later. The final expression result display continuously as users build. They can verify business logic before deployment. The combination of decomposition and real-time evaluation really transforms debugging. Instead of analyzing failed complex expression in production, users test each component during creation. This approach shifts error detection from runtime to authoring time, which significantly reduces implementation delays. And here is the bonus feature that makes life even easier. We have identified common patterns that appear repeatedly in clinical forms and wrap them into pre-built macro tokens. So what's the most common pattern? It is getting answer values from questionnaire response items. Normally, this requires navigating through the questionnaire response structure with repeat if you have many nested items, and then calling where, and then accessing answer.value fields. So it's the same pattern every time, but it's tedious to build. So we created a macro token for it. When you need an answer, you just select the macro and pick the question you want from dropdown. The system generates all the underlying FHIR-paths automatically. You can think of it like a speed dial on your phone. Instead of typing the full number every time you press a single button. So we have taken all these concepts and built them into an open source FHIR-path editor. It's a React component, so you can drop it right into your project where you want to provide FHIR-path editing tools for your users. The API is straightforward. You pass in your original expression and provide sample data for runtime, real-time evaluation. This should mirror your production environment. If you are working with patient data in production, provide a sample patient resource. Same with external variables. Use the actual names and realistic values that will exist when deployed. And as an output, you get updated FHIR-path expression. So let me show you how it works. So this is the playground of the FHIR-path editor. On the left side, you see the editor itself, and on the right side, you see the compiled output. So let me show you how you can add more tokens. For example, if you want to add +3, you first select an operator and then choose number token. You can edit the token. Yeah, and you see the output immediately. And here is the compiled FHIR-path. You can declare variables. So let's say string value. and we named it automatically as var1. As you can see, we use standard function define variable. So it's the standard function comes from FHIRPath, and we wrap the final expression into select to keep the chaining format of the expression. And let me show you the autocomplete drop-down menu. So we have multiple sections. Those are variables, literal values. You can see all the literals, functions, and fields. So, for example, if you want to add a date value, you pick date literal, and then you can choose date value from drop-down. This is much easier than manually changing the text. Also, there is a quantity input, which is a composition of two values, a numerical value, and then the drop-down for using unit. So everything is visible and compiled on real time, and you always see the value of each variable. And also, you can feed your sample data and values for external variables into the editor, and then you can run your FHIR expression on them on real time. So let's say you want to get the name from a patient resource, the patient variable. For that, we need to add a patient and then access a name field. So yeah, you can always search for the needed thing. And let's say you want to filter the name using the use field. For that, we need to call where function, and then we can specify the criteria expression for the function. So we say use. As you can see, the editor already knows that it's right now operating on human name element resource. So it correctly suggests all the fields of human name. Then you can compare it with constant value official, for example. Yeah, you see that it returned a list of one element, the name, which corresponds to use official, and I can further drill down to other fields like family. Yeah, so what else? Let me show you the macro token I've been talking about. Macro token, yes. So yeah, for that we need to go to real integration. So we have here 8-box forms builder. As you can see, I've already added 2 fields. And let me show you how we can add a new dynamic field which calculates BMI. For that, I will add a new decimal field. Let's call it BMI. And go to calculated expression field and toggle the visual mode. This is the FHIRPath. So right now it knows everything about the questionnaire you are working on, and correctly suggests you to pick the answers from the form. So I can say I want weight divided by height squared. So let's call power function and specify the number. Yeah, so if I now enter some random data, you can see that the questionnaire response is fed back to the editor, and it shows the value just like the form preview. So this is the simplest demo. You can always decompose your expression into meaningful variables if they get large. So let's say we declare a variable weight and then height width, like that. Then call power and specify. And then here you can refer to those variables. And then, yeah, weight divided by height squared. So this is the same thing, but more maintainable. If you want to add more expressions, it will be much more easier to test and debug. So yeah, that is the demo. Let's get back to slides. So let's talk about what's coming next to our FHIRPath editor. We are planning to add FHIR query support right now. If you need to pre-populate a form with patient data, you have to handle that separately. But with adding support for FHIR query language right into the editor, you can define queries that fetch data and use those results in your FHIRPath. So one unified authoring experience. We are also extracting our type analysis library into a dedicated NPM package, so other tools or editors can leverage our type tracking logic for their own auto-completion features. Things like Code Mirror, Monaco, or any custom editor that needs FHIRPath intelligence would benefit from it. And we are working on better error messages. Instead of just saying something failed, we'll provide actionable hints. If you are comparing a collection to a single value, we'll suggest using exist or first functions. So that would be a real guidance, not just error codes. So our ultimate goal is to keep lowering the barrier for clinical form designers. And we want every clinical user feel confident building dynamic forms. Yeah, that's it. I'll be happy to answer your questions.
Thank you, Olim. We have a couple of, I would say, questions and comments on the QA tab. The decomposition approach requires some discipline from the users. Without it, the live evaluation would not be useful. How do you drive users to start using the decomposition?
So we have moved the variable selection panel into the first place. So this is what user sees when opens the editor. And there is no really strict constraints. User can always build long expressions using just final expression. But the real-time evaluation only shows a single value. So that might be a good signal for them to split the expression into smaller chunks and move them up here.
Any concerns about the duplications of the blocks?
Duplication. So yeah, system tracks duplicate variable names. For example, if you want to redeclare weight, it just doesn't allow you to do that. So you have to pick another name. Yeah, there is a validation for that.
Thank you. Any other questions from the audience? We have 2 more minutes. Okay. Instead of visual editor like this, I think non-developers would benefit more from an AI interpreter that can read, I want all patients that have a family name with start with pop. I know
Yeah.
you guys have experimented with it.
Yeah, that's
What are your
a
thoughts?
totally valid point. So AI is a good instrument for bootstrapping your logic. For example, you can describe your use case and it will generate you a totally valid FHIR-path. But if you want to fine tune or change some part of it, you need an instrument or just a text editor for that. In that case, things like these tools would be useful.
Great. Thank you so much. We are almost out of time. Yes. Thank you, Olim. You
Thank you.
shared the links to play with it, right?
Yep.
If not, just put it on the chat. And for us, it's time to move forward.